Hey guys, I just wanted to finish the notes from class. We talked about an LRAM using the sigma notation, the right RAM using the sigma notation. I know I'd used a different letter in class, but it doesn't really matter. It could be x sub I as long as that's I and that's I. This is the LRAM, this is the right RAM. These two sums are called Riemann sums. So if you can just add that in your notebook, please. This is what a Riemann sum is, the sigma notation. And then we talked about let's let n approach infinity. Let's get the number of rectangles to get larger and larger, have them approach infinity. And as the number of rectangles are getting larger, this width that represents the width of each rectangle is going to get really, really small. So once I take the limit of these two Riemann sums as n approaches infinity, that's where a definite integral comes from. And I already wrote this in class so you don't have to write it again. This summation s transforms into an s. The function that you're working with is just f of x. dx is delta x transformed into a dx. And then because we're finding the area underneath the curve from A to B, that's where the A and B go. This is showing a product. This is not showing a product. The dx is, at this moment, just there for decoration. So let me make sure we know how to say this out loud. It is the definite integral from A to B of f of x dx. That's how you say this. This is a definite integral, and I keep emphasizing definite because in the next chapter we'll work with indefinite integrals. So right now it's a definite integral from a to b of f of x dx. I'm not sure if you need to write this down, but I do want you to write down the following. So the limits of integration, the limits, and this word limit is not taking limits that we did in chapter 2. It is not the limit as n approaches infinity of these sigma notations. That's not the same limit concept. The limits of integration, they are from A to B. So that's a limit of integration, A and B. The other thing I want you to be comfortable with is f of x. The function you're working with is called the integrand. That's the function you're working with. And now, in this case, x is the variable of integration. That's what x is. So this is called a definite integral. These two are limits of integration. F of x, the function, is the integrand. If the variable is an x, like you can have a definite integral go from a to b, and it says v of t dt. This t will match up with this t, and the variable of integration is t. You might have an r, and the function is, let's say, a of r, dr. And then this goes from, let's say, 0 to 5. The variable of integration is r. Okay, so now we're going to do a little example just to help you understand the parts one more time. If they say the integral of x squared dx, and the limits of integration go from 1 to 4. What this represents, I'm going to draw x squared, my function. Here's my x squared. I'm going to eyeball 1 right there, 4 right there. This represents the exact area from 1 to 4 where the function is x squared. This is what this integral represents. So if it says evaluate, it says evaluate this integral. You sketch x squared, you close off a region from 1 to 4, and they're looking for the area underneath the curve bounded by the x-axis. The x-axis, boys and girls, is always a boundary, and it starts at 1 and it goes to 4. So vertical line at 1, vertical line at 4. Now, how do you find the exact area? We're not going to learn that until probably next week. not in this current section. This current section is all about understanding what this means and what it represents. So it represents the exact area. What you can do at the moment is, you can estimate this. You can estimate this integral. You can draw a midpoint ram or a right ram or a left ram and estimate the area underneath the curve. So you can sort of estimate it. We're just not there to find the exact answer for this integral. And again, if your integrand is velocity, and the time goes from 0 to 5, then the answer, if this is velocity, let's say feet per second, then the answer represents the distance traveled. That's what the answer would represent. That's what we talked about the first day we started this chapter, that if given the velocity curve, or the graph of velocity, then the area underneath the curve represents this distance traveled from t equals 0 to t equals 5. Okay, let's go on to our packet. Pause the video if you don't have your packet taken out. I'm looking at page 6 from the packet. Page 6 from the packet. So, again, 1 to 4 tells you that you're going to find the area underneath this curve, x squared, between 1 and 4. That's what it means. So I'm on page 6 of the packet, and we're looking at this definition that's in the box. So I have a function. My integrand is non-negative, or my function is positive. My function is above the x-axis. So in this case, if I have x squared, it's above the x-axis. So I have a function that's not negative, and it's integrable. I'm not sure if I'm saying that right. Integrable just means it has an integral, and we have a closed interval. This integral represents the area underneath the curve of f of x from a to b. That's what this integral represents. That's not anything new. I just showed you that if you have a definite integral of x squared dx from 1 to 4, it just represents the area underneath the curve. This is saying the same exact thing. It's just specifying that if the function is positive, meaning it's above the x-axis, if f of x is greater than 0, then it represents the area, which totally makes sense because, like, how do I have area to be negative? Like, if I have a curve that's below the x-axis, like here's a curve below the x-axis, this region is below the x-axis, so I don't know if that's going to make, like, area can't be negative. But we'll talk about that when we're together in class. This is saying that if the function's above the x-axis, then this integral represents the area underneath the curve. Let me remind you, one of your boundaries is the function. I just did it here. One of the boundaries is just the function. Another boundary is a vertical line at x equals 1. Here's my vertical line. My third boundary is x equals 4, and the x-axis is always a boundary. So we've got the function, the lower limit of integration, the upper limit of integration, and the x-axis is a boundary. All right, now I want you to do number 1 for homework, A, B, C, D. E is kind of interesting, so try E.